go. All right. So, without further ado, let's go. We are going to start with Jessica making music with code, and then Alec is going to be on deck, and then I will disconnect and get out of the way here. And do you need the HDMI cable? Cool. So that's that. This cord. It's gonna be fun. And do you need a moment? Should I dad joke it for a minute? Cool. So I do want to warn you. I've got some dad jokes prepared. They're just how I roll. Yeah. Okay. Okay. So my name is Mike. I live in Cleveland. I love Cleveland. Cleveland is great. I'm a big fan of Cleveland architecture. In fact, I'm so inspired by it that now I've started stacking all my command line windows vertically. You know, a terminal tower. And while we're talking about architecture, do you know what a pirate's favorite Cleveland building is? The arcade. Seriously though, if you're not from Cleveland, you should go check it out. It's beautiful. Even Lois Lane thinks it's super, man.
I think I'm ready.
You ready?
Yeah, I think so.
All right.
Cool.
Jessica, take it away.
Yeah. All right, I'm going to make some music for y'all. I promised you I would do that yesterday, so you should be getting music. Is that coming from? Cool. Everyone, can people hear that? Cool. All right, let's start this. demo even more.
All right, thank you, Jessica. All right, Alec is up next with porting CPython to CircuitPython. And Joe, you are on deck. We have Alec. Cool.
HDMI.
And then Jessica, is it okay if this gets unplugged? Okay.
Do we
got
wait?
it? Thank you.
I'll steal that back.
All right. Do I need to kill time for a second? Are you
What?
good? Or
Red-
I can stall for a minute.
Do you want to tell a dad joke?
I mean, I can.
I would like to hear a dad joke.
Sure. So, you know, they say that the stadium here, is anybody a baseball fan? Baseball stadium here, they say holds about 34,000 people, but that's just a ballpark figure. Do you know why the stadium gets hot after games? Because that's when all the fans have gone home.
All right.
Yeah, we're good there?
We're good.
All
We're
right.
good. It's a good stopping point.
All right, take it away,
Awesome.
Alec.
Thank you. All right. Hi, everyone. My name is Alec Delaney, and I'm here to talk about porting CPython to CircuitPython. So first off, what is CircuitPython? CircuitPython, if you were at my talk earlier, you heard about it, but I'll go over it. It's basically just Python for microcontrollers. It's made to run in constrained environments, so your computer has more memory, more other things. CircuitPython is made to run on these systems that don't really have that, right? They're just microcontrollers or chips, things like that. It places a major focus on beginner friendliness, speed of development, and out-of-the-box support. So there's no complicated like compilers or tool chains, right? Like JLink, I don't even know what that is. You don't need it here. You basically should be able to plug in your microcontroller to your computer and start writing code. And it works essentially like a specialized subset of Python. But let's take a moment and kind of break down what that means. So specialized subset, what does that mean? Well, specialized, it's specifically made for microcontrollers. So again, memory-constrained environments. It includes functionality unique to embedded systems, right? So now you can do things like I2C and SPI, things that your computer just doesn't expose to you. And it means that every chip is slightly different, right? So CircuitPython for one board looks a little bit different from CircuitPython on another for that reason. And being a subset means that it only includes part of the CPython standard library. Anyone at my talk saw that we can use the time module, but there are plenty of other modules that aren't included, right? Again, memory constrained, we can't have everything. Even when things are included from the standard library, it might not be everything, right? You might have a module that you're familiar with, but you only have parts of it. And what is included needs to look very similar, right? You don't want to have to remember two languages. We want Python to be Python, so it should look and feel very much the same. But these can be really conflicting, right? And it basically boils down, in the Zen of Python, to special cases aren't special enough to break the rules, although practicality beats purity. So we need to figure out how much of Python to include in order to make the user feel that they can approach it, but not so much that we can't run it. And CircuitPython does this really well, so why would we want to port more, right? We already have the time module. What else could we use? Like, why would we even need it? I can name a couple of reasons. One, it makes your code more readable, right? Things like decorators that CircuitPython has some support for. Being able to use more decorators makes your code a lot more readable from the get-go. It's also simple for the same reason, right? You can look at your code and it's very clear what's happening. It makes it easier to review, right? Giving someone else your code that's familiar with Python, they can now look at it and say, hey, yeah, that looks right, or hey, you should do that. It makes it easier to use tools, right? Being able to use the tools you're familiar with, and the things like your linters are already familiar with regular Python code makes it very much easier in that regard. And finally, it's fun. I do like a good challenge, right? So being able to add more things from the Python standard library to these microcontroller environments to write better or more readable code is super fun. So some things I've ported as an example. One is the CSV standard library. It's a great library. Again, I am a hardware engineer, so CSVs are life. And that wasn't included in the CircuitPython library because you can already write files, you can already add commas and write text, so you can do it yourself. But I found myself doing it so often that it made sense to import. Again, this is a very almost dumb small version of it, right? It literally just writes text and numbers, puts quotations where it needs to be, and then slaps that in a .text file, basically. So very, very simple, but gets the job done. And similarly, func tools, this was a particularly interesting one. I recently looked back at this and added the cache function, which had some very unique quirks because the way CircuitPython works with functions is that they are first-class objects, but once you start doing some weird things with them, it gets a little mucky. So this was a very fun, interesting challenge I recently did. So let's talk about that. What are some of the challenges? Well, first of all, for memory reasons, CircuitPython makes compromises of what you're allowed to do and what you're not allowed to do so that more things can be baked in, right? We have a lot of functionality to pack in, and we need to put it somewhere. So CircuitPython makes some of those compromises. Additionally, some of those things are impossible, right? You can write type annotations, for example, in CircuitPython, but you actually can't reference them when your code runs. So trying to reference any of your annotations, they get discarded. So for example, data classes you can't do because you can't use type annotations. Arguing with a very angry linter. I've done this multiple times. This one speaks for itself. And also really thinking about how much should be ported. Some solutions, I think these are applicable in general. I would say build with the existing functionality, start using Dunder classes, those are available. Focus on the feel, and thank you.
All right, thank you, Alec. Ooh, is that thunder? That's exciting. All right, next up is Joe with the beauty of Zipapps. Christopher, you are on deck.
That's part of what I want. Well, almost.
You need a second? Okay, cool. Well, so, you know, most people, they're shocked when they find out how bad of an electrician I am.
One more. That's it.
Okay. You know, when you think about it, the shovel was truly a groundbreaking invention.
I actually really liked that one.
Yeah, I did too.
Yeah, darn you anyhow. Yeah. Okay, rock on. So, hey there, my name is Joe. I really like to talk, and if I do this without a script, I will go over. So I have a script, I'm sorry. So, we're gonna talk about the beauty of Zipapps. First, rewind to 2008. Not quite that far. The introduction of Python 2.6 brought us lots of cool features like multiprocessing, native JSON support, existential angst about the upcoming Python 3. We got Sphinx as a documentation platform and the with keyword. We got the -m flag for running a module as a script. We got string.format. We got the IO module. We got buffer protocols, abstract base classes, class decorators, and fractions. I was off by one, but that's okay. And buried very deep inside that long list of very cool things was a single paragraph that explained that you can now run Python directly from a zip file, which was extremely exciting. This change went relatively unnoticed until 2013, when PEP 441 improved Python zip application support. When the Zipapp module was added into the standard library in Python 3.5, that's here, it got a whole 3 sentences in the release notes. So I think it's really safe to say that most folks haven't interacted much with this system. This was super exciting because you can put all your source code into a zip file. You can pass that archive on to someone else who has Python installed on their computer, and they can just run it. It's a single file, it's beautiful, it's easy, and it has one gigantic issue, namely, you cannot package third-party dependencies in a official zip app. We're gonna fix that. So you can only write code that relies on the standard library. Now, for some, this is not a real blocker, but for a lot of us, this is a magnificently huge blocker. And I want to tell you about something that I've been working with a lot called Shiv from the folks over at LinkedIn. This is the only cool thing they've ever made. It allows you to create Zipapps that bundle their own dependencies. Imagine a set of data science scripts with a carefully manicured virtual environment that you can shove into a single file, pass off to someone else, and it just works. No environment setup, no mess, no fuss, no nothing. Now, some of you are internally screaming, what about PEX? PEX is another awesome tool that does this, written by all those really cool people from Twitter who aren't there anymore. The docs for Shiv go into more detail, but the short version is that I'm reasonably sure Shiv is faster. Probably, I haven't checked myself. Your mileage may vary. So containerization with tools like Docker is a lot of overhead for relatively little benefit if you're dealing with really small apps or a one-person dev/DevOps team. Plus, it adds a lot of DevOps-specific work to the maintenance burden, which is fun for maybe 4 people total in the audience. What about actually deploying with Docker? Starting with a Python 3.13 image and copying the single compiled binary into it is guaranteed to work. It's a bit silly, maybe, but for an environment that's pre-built for success. As a kind of a corollary, this is the normal Docker deployment for Azure. This is kind of what doing a small deploy with a Zipapp looks like. And so now to the modern day, this is me. Thank you very much.
All right, next up is Christopher with Goodbye to From. JR, you are on deck. I'll give a moment here. Let's see. Okay, we're going to go back to pirate jokes for a second. Everybody knows what a pirate's favorite letter is? Yeah, you might think it's R, but his first love be the C. Good to go?
Yes.
Okay, thank you.
Goodbye to From. I'm Christopher Neugebauer. Hi. So Python is great. It has namespaces. Namespaces let you keep similar functions grouped together, and that's great. You know that you have a maths function, so you find it in the math module. But when you find yourself typing out math over and over and over again, it can get really tedious. And wouldn't it be nice if you didn't have to do that? Well, you can. We can get functions by unqualified imports. And now that we've done an unqualified import here, we don't need to type math all the time. It was getting really difficult there. My fingers were getting tired. But unqualified imports have a problem. If 2 modules have things with the same name, it can get really easy to step on your feet. And this is bad. And with that going through my head a few months ago, I saw this post from Thea on the socials. If you have a part detector and a result data class, what do you call that data class? Part detection result or result? Brett Cannon, the arbiter of all good taste in Python, says result. Thea then points out that there are a lot of part detectors, and using result will result in a lot of unqualified imports. And Brett says that's a Thea problem, and you should be using unqualified imports, and so you should be using qualified imports, and unqualified imports are bad. And if the anointed arbiter of all good taste in Python says that it's important, it must be important. So let's make it mandatory. Here's a class called mustBeQualified. We raise and catch an exception so that we can get a copy of the execution traceback and know what our stack looks like, and we pass that stack to a function called errorIfUnqualified. Now we use that traceback to walk backwards through the traceback to find the init method of the class that we're in, and grab its code object and storing it as relevant CO, storing the place where the init object was called as well. So now we can get the name of the enclosing class and the module that it's enclosed in. And then we can use the dis module to inspect the bytecode that we stored. Oh yeah, Python has a built-in bytecode disassembler. It's pretty cool, you should look at it. Anyway, we can now look for the instruction that's on the line of code where our init is being called, check to see if it is using the actual module name in there and the class's name directly. If it finds such a line, it breaks. If it doesn't, well, this is a for else block, my favorite piece of Python syntax. So we raise an exception. For else, hooray. So now you can write a class that inherits from mustBeQualified, and if you instantiate that class as an unqualified import, things will blow up for you. And if you instantiate it from its module, it will succeed. This is perfect. How else can you use this? Who here uses Django? Who here is annoyed that you have 5,000 files all called models.py? And they're really hard to understand in context. Well, you can put a call to this function called force models qualified at the end of your models.py file. It will look for every model class and force that to be instantiated using a qualified import. And with that, can you import an individual model definition? No, you can't. Can you import an app's models file with a new name to make it more convenient for you? No, you cannot, because that confuses people. The only thing you can do, importing the module with its actual name. And now you can understand everything. And if you want others to understand everything, you can add it to your own code. With pip install from less. Hooray! And with that, you can say goodbye to from. Okay, but back to Thea's original request. Like, we have namespaces. Just put like the result class inside the names inside the main class. That's what namespaces are for. So much better. The end. Also, I run a small Python conference in a barn on a ranch in Northern California. If you want to partake of a conference experience curated by the brain that produced this talk just now, you should go to nbpy.link/subscribe and get notified of our key dates. Important, there are friendly, socialized barn cats who you can meet. And okay, thank you. I've been Christopher Neugebauer, and goodbye to from.
All right, next up is JR with I Am Not a Python Developer. Ben, you are on deck. And I'm sorry that we don't have cats here. It wasn't a thing we could do.
All right, I'm going without slides, but I want to hear a dad joke.
Okay, let me see where I was at. Okay, so we're still in pirate jokes. Do you know why pirates like going to the opera, JR?
No, I don't.
They go for the arias and the high Cs.
I like it. Nice. Okay, hi there. I'm J.R. Rickerson, and I am not a Python developer. Or I could also say I am not a Python developer. But maybe that's not unusual to say at a Python conference even. But I will also say you are not a Python developer. Everybody in this room, you are not a Python developer. And before everybody attacks me for gatekeeping, just bear with me for a minute. What I will say I am is I'm a human being, right? And I assume most of you are. Apologies to any pod people in the room. I am not, however, a human resource, right? I'm a human being. I did learn Python. I do like Python. I use Python for my work all the time. It's a lot of fun. I like being here with you all. However, I also like disc golf. I also like baking bread. I also enjoy classic video games. I enjoy punk rock. I enjoy hiking. I enjoy spending time with my family. I am not a Python developer. How could I be just a Python developer, right? That's one thing that I learned. That's one thing that I do. So, the dark secret, or that one secret trick that employers don't want you to know for the clickbait title, I learned all those things that I just mentioned, right? Turns out that we all start at ground zero, and we all have to learn everything, right? I don't know of any babies that show up coding Python, right? Maybe you do. But I learned everything that I enjoy. I learned Python, I learned baking, I learned disc golf, all of my other hobbies and interests. I can learn other things too. I'm learning things this weekend. However, if we take a look at IT industry jobs, right? A lot of folks are out of work right now. A lot of folks are looking at job postings, right? What do they all say? They all say, we want a Python developer, right? They say, we want a JavaScript developer. We want a full stack developer. We want a DevOps person, right? Or even more specific, a Django developer, a React.js developer, whatever, right? They want that one thing, like that's everything that you are. And why is that? Well, it's easier, right? When you're producing a job ad, it's simple to just throw it out there. That's what we want. It's cheaper, right? You don't have to have somebody think about what you actually need as an employee, or think about the fact that you might have to train them a little bit or something like that. But it's also because we allow it, right? So, I am not a Python developer. You are not a Python developer. And you are not a human resource. Don't allow it. And that's easy to say, but I know a lot of people are out of work, right? So here's what we can do. Let's apply anyway. If the job ad says React.js developer with 10 plus years experience, apply anyway. You can learn it. If it says Python developer with 5 years experience, apply anyway. You can learn it, right? Tell them, I'm a professional, I can learn that. Or, this is a little bit harder if you're in a tough situation, but walk out of the interview. If they're depending on you to be XYZ with this many years or whatever, don't stand for it anymore. We don't need to. And that's all I have to say.
All right. Thank you, JR. Ben, you are up next with talking about an agentic coding UI. Very exciting. Elizabeth, you are on deck. Where's Elizabeth? Cool. Awesome. And while we get that settled, I'll finish the pirate jokes. Do you know where Captain Hook got his hook? From a secondhand store. All right, do you need a second yet? All right. Do you know what really bothers me? When somebody comes waltzing into my office when the music is clearly in 4/4 time. Are we having fun AV challenges? Cool. I got another music joke. Do you know what kind of music balloons really hate? Pop. Yeah, nailed it. Ha ha. Let's see. I gotta figure out where I was at here. You ever heard of a music group called Cellophane? They mostly rap. Yeah. Okay. We good? No, still need a minute. Okay. Okay. Technical fun difficulties. Yeah. Where was I? Okay. So you know, I recently I bought a secondhand time machine next Sunday. They don't make them like they're going to anymore. And on the subject of time, what did the digital clock say to the grandfather clock? Look, no hands.
Thank you so much.
All right, we're good to go?
All right.
Awesome.
I think we are good to go. All right. So let me just go full screen here. Okay. My name is Benjamin Patch. You can follow my dev blog at benjaminpatch.com. And I am here to talk about my agentic coding UI. Okay, so I've been exploring agentic coding. And if you're not familiar with that term, it simply means using an AI agent, you know, to assist you with producing the code that you're trying to build. And there, of course, are a plethora of these new agentic IDEs that are hitting the market. You know, we saw the demo earlier, using Windsurf, and Cursor is well known, Replit. I think you can even classify VS Code when you're using GitHub Copilot with it, and something like Zed and the agent panel. All of these can be considered agentic IDEs. But my problem with them is not so much what it's producing, because I can work with that, but it's the UI. And that's, I think they all have a critical flaw. And this might sound a little unorthodox to Python developers, but they're putting the code at the front and center, like a traditional IDE would do. And that's a little bit of a problem, because you're using your agents to produce the code. And especially when you start using multiple agents at the same time, it really becomes, the job becomes managing the agents. And then if you're just pushing the agent off to a sidebar, then the interface is frankly difficult to get what I would consider productive work done and to get the most out of what these systems have to offer. So what they're really selling, the more advanced sources, the more advanced IDEs like Cursor, it's really the proprietary agent orchestration. Okay, so they're trying, you're giving it a prompt, and they are adding additional material to it to help it generate what you want and what's something that's usable for you. But I would say, with the advent of these powerful CLI agents, okay, so command line interface agents using the premium, what are considered the frontier models from all the major providers, Claude Code, OpenAI Codex, Google Gemini CLI. These products, I personally have had much better results from, especially Claude Code. I've used that the most out of all of these. And because they run in the terminal, essentially, we can conduct the orchestra ourselves. We don't need, in my opinion, these other commercial products that are trying to get in the way and making decisions that we're not even aware of, you know, to produce the code. And the way I do this, I've been experimenting with different workflows, is essentially to make that agent management front and center in my user interface. And you could do this in VS Code by moving, you know, tabs around and things like that. It is possible to set up your IDE like that. But a much simpler solution is, you know, to make the code the sidebar, if you will, is to set up a multi-terminal agent UI. So all you're doing is taking, you know, I use, for example, iTerm on the Mac, and there's plenty of other options out there for what you need to do. Split up the command line into as many agents as you need. Like in this case, there's 4. And instead of using tabs, I've seen some developers just open different tabs that you can't see simultaneously. Run it like this in your UI, and then, for demonstration purposes, you can do advanced setups like this, and without having to touch the interface, you can be monitoring at the same time exactly what all of these agents are doing. So for example, you can have Claude Code writing your feature number 1 backend, and then in a separate terminal, in a separate instance of Claude, you have it writing feature number 1 front end. And then maybe Gemini is writing the tests that will be testing this code. And then you could use Codex for feature 2 planning, which you can then cycle through. And when you can see everything like this, you're putting the agents front and center, and there you go. That's what I had to say.
All right, thank you
very much.
Very much. Elizabeth, you are up to tell us about hydroponics. I'm excited about the rest of the time. I'm going to let that be a surprise for our audience. And Destiny, you are on deck. And just as a quick public service announcement reminder, we do require masking at the event, so if you take your hand and touch it to your face and there's not a mask in between your hand and your mouth, please grab a mask from registration or from a friend nearby. I have a bunch in my backpack as well. We do need you to be doing that. That's the policy to be part of PyOhio. So thanks for folks. I wish you can do that for me. Thank you. You need a minute, or I could do terrible dad jokes.
I don't know if I want that.
All right. Cool. Well, it looks like we're ready.
Well, this is my one pearl joke, right, about programmers. What are the 3 things? What are the 3 virtues of programmers? Laziness, impatience, and hubris, right? Woo. And I'm going to apply that to hydroponics, probably not in the same way it was intended. So a lot of people get into hydroponics because, you're coding and you're doing all this electronic things, and you think, great, the next step, I'm going to grow things, right? I'm going to have plants. I'm going to have a whole hydroponic setup. Maybe I'm going to go on Amazon and buy one of those fancy little setups. This is not for you. This is the talk for people who just want to put together something with what they have. So, first virtue, laziness, right? What's the easiest way to do hydroponics? The crack key method, right? You mix up the whole solution, you put it in a bottle, you put a plant in it, and you don't touch it again, and it grows you something, right? Usually you use that for things like lettuce or things that you're gonna harvest. Problem with it for me, doesn't feel like a hobby, right? If I just mix something, put it in a bottle, leave it alone, I don't get to tinker with it, right? I don't get to mess with it. What do I wanna do that for? On the other hand, if you like that, it's a great way to go. It's also not good for fruiting plants. So if you want like tomatoes, peppers, things like that, not your method, right? A lot of people, they like to get all technical with these things, right? They want to get their Raspberry Pi, they want to set it up, they want to do coding. You're wasting your time, okay? Let me back that up. The majority of what you're going to do and the majority of value you're going to get out of it doesn't involve any of that, right? Can you optimize? Sure, right? But I'm an engineer, right? I work in manufacturing. If I'm only getting a 5% improvement, I'm not necessarily putting my time in that. You're not running a hydroponic farm, you're just screwing around at your house, right? You can do all these things. They don't add value to me. Soil dryness sensor, just water the thing twice a day. pH, electrical conductivity, change your water. Temperature sensor, are you growing these things outside? And yeah, you can put a camera on your Raspberry Pi and look at it, or you can just put a webcam. Personally, I think this is all overdoing it. Laziness, some other techniques that people use for hydroponics, and I'm gonna tell you no. Nutrient film, it's when you have water pouring over your roots. It's too fiddly, you need to monitor it so it doesn't dry out. Aeroponic systems, a lot of specialized equipment. Drip systems, specialized equipment. Wicking systems, seems pretty low tech, but let me tell you, it will break down constantly. This is not the person whose things go well hydroponics. This is a disaster hydroponics. So I'm gonna recommend deep water culture, right? What that means, you have these little pots, you put them in a big bin full of nutrient solution. There is no soil, there's just rocks. The roots reach down into the water, there's a little aeration going on, and you get plants. These particular ones are tomato plants. Next thing I'll recommend, flood and drain, or called ebb and flow sometimes. These are drawers, you know, like those stupid plastic drawer sets you get that, break and are terrible and collapse and bent. This is what you can use them for. These are little fabric pots you got here that I made out of a big roll of landscape fabric. You sew them up, you put coconut coir in them, you put your plant in there. Usually twice a day, you get a pump that goes from this reservoir down here, that green thing. It floods the entire drawer with nutrient solution, and then it drains it all out. That's all you do, and you get these really, really big tomato plants that come out of it. Very easy, very foolproof. They don't dry out. Even if your power goes out, you're not going to lose your plants. I recommend that system a lot as well. Next thing I'm going to say is impatience, right? Impatience because when I get a project together, I don't want to have to order on Amazon. I don't want to have all these things. I don't want to wait for people to deliver to my house. I want to do something right now. So for me, that's what impatience means. Everyone will tell you need fancy grow lights. You can get these lights at Menards for $9, right? They'll get the job done. Just as many lumens as you can. This hydroponic solution, any kind of indoor gardens or place that you can realistically buy things to grow weed, you can buy these instead and grow tomatoes. For flood and drain, all you need is coconut coir, basic timer, pots, an aquarium pump. For deep water, you can 3D print these little net pots. You have a little aerator that you can throw in your reservoir and a bunch of river rock instead of soil. Hubris, the problem is you're gonna get so into this. You're gonna grow all these tomato plants. You're gonna break off your little edges. And eventually you're gonna end up with 34 tomato plants in one of your rooms. These things will drink themselves to death. They consume so much water. You will find yourself with a hose coming from the outside of your house, in one of your windows, changing your water. Not because of a failure of automation, but because who has a hose hookup inside of their house? So, like I said, it's a great hobby. It's fun to get into. You can optimize it a lot, as I'm sure you all like to, but you can also get yourself in a situation where one of your spare rooms looks like a dead space station full of dead plants and broken dreams. Thank you.
All right, thank you very much. Destiny, you are up next with import accessibility as default, so come on up. Oh, yeah. Yes. Yeah, great. And Jeff, you are on deck. And in the meantime, I'm going to ask you a question. Do you know why programmers prefer dark mode? Because bugs are attracted to light. Yeah. Yes. Carl, you all still recording good? Cool, all right. Do you know why Python programmers commonly wear glasses or use contacts? Because they don't see sharp. All right, looks like an AV moment here for a second. All right, do you know the first time I purchased a universal remote, I thought, this changes everything. All right, you know, I've been trying to come up with a dad joke about momentum, but I just can't seem to get it going. Yeah, okay, maybe we good to go? All right.
Okay. Hello, everyone. My name is Destiny O'Connor. I'm a web developer for Women Blessing Women, and I'm an educator for Deaf Kids Code, and I'm an accessibility advocate for the Cloud Native Computing Foundation, the Deaf and Hard of Hearing Working Group. And also, I'm deaf, but I can speak and I sign at the same time, too. Okay, so what is accessibility? Closed caption, sign language, large printing, assistive listening devices, braille, and accessible, making the event accessible. So let's talk about the gap in tech, the accessibility gap. Deaf and hard of hearing people face barriers in tech events, meetings, code bases, and documentation, like missing caption, unclear jargon, no sign language terms for tech concepts, just basically no access. So how we're closing that gap? We've created a sign language tech glossary for key terms. We developed documentation and resources for accessibility, and supported deaf and hard of hearing individuals in tech, and advocated accessibility for open source and community events. So this is what our working group does. We create documentation to provide for anyone to look at to see how you can better your event and make sure that you provide access for it. And PyOhio did amazingly with that when I asked for interpreters. And so thank you so much for that, for providing interpreters for me. So why does it matter? Deaf and hard of hearing people bring unique perspective to tech. Accessibility benefits everyone, not just one group. Inclusive communities create better innovation. Open source grows stronger when everyone can participate. So since we did all of that, made documentation and all of that, we started making history. I became the first deaf keynote speaker as part of the panel discussion for KubeCon. Anastasia, one of my other co-workers, became a keynote speaker as well in London, and she became the first deaf CNCF ambassador. And then Rob Cox made history becoming a solo deaf keynote speaker. And 3 of our working group members received a Breaking Barriers Awards from Google. And we also open source our accessibility documentation, inspiring other tech conferences to adopt and share accessibility practices. And representation matters. Visibility opens doors for others. I don't know if you guys noticed, but Apple started having ASL. For any of their big conferences, they started having interpreters showing on the screen. Google is starting to do it. GitHub is starting to do it. We're trying to create more of that, the visibility and everything, so you could see that we exist in the tech world too. Accessibility isn't optional. It's essential for innovation. So add caption, transcript to Python talk to project, contribute to accessibility documentation, partner with deaf-led groups or any other group that they have, and make accessibility a default practice, not just an afterthought. Thank you so much. My name is Destiny. You can, these are QR codes for if you're interested in Deaf Kid Code. here in Cleveland. I will be hosting those sessions specifically for deaf kids. But if you know someone that is deaf or if your child is interested in learning sign language, they can join too. For the Cloud Native Computing Foundation, the Deaf and Hard of Hearing Working Group, if you're interested in that, that's the QR for that to join our working group. And then this is my LinkedIn if you want to reach out to me and ask me more questions and learn more about what I do. Thank you so much. Thank you for having me here. Oh, thank you. Yes, thank you. Nice meeting you.
All right, thank you so much, Destiny. Jeff is up next to talk about MacroPython. Aha. And then Wagtail, Vince is going to talk to us after that about Wagtail. So Vince, you're on deck. And in the meantime, let's see. Oh, it's almost the best time of day. Do you know what the best time of day is? 6:30, hands down. Yeah. Did you all know that Albert Einstein was actually a real person? All this time I thought he was just a theoretical physicist. Do you know, let's see, Jeff's good? No? Okay. Do you know what the difference between a hippo and a Zippo is? One is really heavy and the other is a little lighter. I'm getting a look from the front row that scares me. I'm not sure how to interpret that. Well, maybe Christopher, do you know what did the ocean say to the shore? It just waved. Yes. Let's see. Do you know how to steal a coat?
So it's not showing up at all.
You jack it.
I'm just figuring that out.
Okay.
What is the correct?
Why did the knife dress up in a suit? Well, wanted to look sharp. Yeah. Let's see. What do you get when you cross a chicken with a skunk?
I do.
A foul smell. Did you know that Vin Diesel only eats 2 meals a day? Breakfast and Breakfurious. Hey, it looks like we almost have slides.
Yeah, we're, I don't know if this is quite right yet.
All right. A raisin, a peanut, and an oat sit down and order drinks. The bartender says, "What do you think this is, a granola bar?" Yeah. Almost. Hey, there we
Okay,
go.
let's do it.
All right.
So hi, I'm Jeff Epler. For much of my Python career, I've worked with CircuitPython and MicroPython. And something put the thought into my head, MicroPython is good for resource-constrained systems, like the Raspberry Pi Pico 2 released in 2024. The price is $5. But the Macintosh Classic, the price is $2,465. The number is much higher. There's something interesting here. So I set about to port MicroPython to the Mac, and I'm calling it MacroPython or M68K MicroPython. And this is a big upgrade because the last version for these computers was in 1999, Python 1.5.2, while MicroPython brings Python 3.6 syntax with lots of good features like async IO, f-strings, and key parts of the Python standard library. So in looking around, I found that there's a modern tool chain that you can build on Linux computers and target these old Macs. It's called Retro68. And another interesting thing about it is it has a version of all the Mac APIs in YAML. So you can read those API declarations and create Python bindings for everything. It's also really easy to test this without hardware on emulators such as VMac. There are some technical challenges. I don't have a lot of time to go into those, but it's a lot of fun. And what can it do? I can pull up QuickDraw, create a window, and draw some lines into it. So I'm having a lot of fun with this project. And of course, it's online and I'm on the socials. So if you're interested in a new Python for classic Macs, please check that out. Thank you.
Thank you. All right, Vince, you are up next talking about Wagtail. And Jayanaka, if I got your name right, I hope I did, you are on deck. And in the meantime, have you all heard of this band called 1023 Megabytes? They're a little obscure. They haven't got a gig yet. Yeah, lately I've been reading a book on the history of glue. I just can't put it down.
Okay, I think we're ready. Hey everyone, my name's Vince, and I'm here to talk about Wagtail. You may have heard of it. If you're a Django user, you've probably... and a shameless plug, I work at Code Red. We are based in Cleveland and here, and we do Django and Wagtail web hosting and development and a lot of open source stuff. So what I'm going to do is just show you what Wagtail looks like. So let's just build a whole website within 5 minutes here using Wagtail. So I'm going to first just pip install Wagtail. Actually, I'm going to be using a extension that we built called Wagtail CRX. Basically, this is just Wagtail with some additional pre-implemented filter features so that I have something to show you. So I have pip installed Wagtail, CodeRed CRX, and I have a virtual environment. So I'm just going to start a boilerplate project. So now I just have kind of a basic Django project right here. So let me set this up. If you've ever done Django, this is going to look familiar to you. So this is setting up the database because Django has a nice ORM that works with MySQL and Postgres. And Wagtail is a content management system for building websites, so we need to store our content somewhere. I'm going to create a user so that I can log into the Wagtail admin. So I'm just going to do admin, admin. And now I'm going to run the Django development server, which is going to fire up my Wagtail website. So that's the only coding I'm going to do. Everything else, I'm just going to show you what Wagtail looks like. So here we have a blank, empty website with nothing in it. But when I go to the admin, this is where I can log in with my account that I just created. And this here is what Wagtail looks like. So if you've ever seen the Django admin, Wagtail comes with a much nicer admin that lets you manage web pages, it lets you upload images, it lets you upload documents, and just do all kinds of content management for your website. So I'm going to go to my home page here, and that's what I was looking at over here. So I'm going to go ahead and edit it. And Wagtail has this really nice editing interface called the stream field that lets you basically build out all kind of content. And what I'm going to do is upload an image. So I created a demo. Going to go ahead and upload an image. And this is functionality that's, it's Wagtail functionality that's been pre-built in the Wagtail CRX package. And I'm going to add some content. So we've added all kinds of content in CRX. That's the open source Wagtail extension. We've added all kinds of stuff for Bootstrap. So in addition to text and images and things like that that come with Wagtail stock out of the box, we've also added a bunch of extra stuff like buttons and more interactive things. But I'm just going to show you some basic Wagtail stuff. So I'll say hello from PyOhio. Let's make that a big, bolder H2. And let's add a button below that. And it's not going to go anywhere. Just do learn more. And let's go ahead and publish this page. So since it's a content management system, you can publish and unpublish and save drafts. And now you see that I've got that image I uploaded, I've got some text, I've got a button. So let's just keep going. Let's build a blog. So I'm going to add a page under here and going to do article landing page. With Wagtail, you can make all kinds of custom pages. I'll just call it Vince's blog. I'm not going to add anything else for now. And now I'm going to add, underneath this page, I'm going to add a blog page. So my first blog post. I'll add an image. Let's upload another one. This is a cool picture of the rock hall. And I can add some, additional stuff. Thanks. So now I'm going to go ahead. Thank you. So check out Wagtail.
All right. Cool. We got Jayanaka coming up. Prompting without prompting. And Mehul, you are on deck. And whilst we deal with the AV switchover, did you know that scientists once tried to make a diamond shaped like a duck? It quacked under pressure. Do you know why you shouldn't buy flowers at a monastery? Because only you can prevent florist friars. Yeah, Christopher's angry with me. I see the eyes. Just confused. Okay. All right. Ready to go. Awesome.
Hi, everyone. I am Jayanaka. I'm a PhD student at University of Michigan, Ann Arbor. I'm in the Secret Research Group, and I'm here to talk about prompting, or prompt without prompting. So what do I mean there? Like, prompt without prompting. Like, prompting is how you, the base way you integrate an LLM into your program, right? If you want to build some AI feature in your program, you need to build a prompt most of the time. But there are some frameworks out there, but we'll talk about that later. So let's say you want a functionality where you want a, let's say you have a name of a historical figure, you just want an LLM to tell you which personality does it want. I know there are like much more number of personalities out there. For this example, let's say there's 3: introvert, extrovert, ambivert. So let's say you want to define this function called getPersonality, which takes in a name, which is a string, and it wants to output this personality, one of these personality enum, right? So this is a simple functionality. How much work do you think that you need to do to get this working with an LLM? You need to write a prompt that explains to the LLM, okay, there is these 3 choices that you can choose from, and you have to explain to the LLM, okay, this is the format that I want this output to be in, and even though you do that and the LLM produces it exactly as the format, you need to write your custom way to actually parse that output and get the personality type and then match it with, let's say you just have an if condition that just checks, okay, intro is there, introvert, extra is there, extrovert, ambi is there, ambivert, some kind of an algorithm that chooses, okay, this is one of the 3. So there's a lot of work that you need to do. How can we abstract this away? So it's just a simple, when you look at it, it feels simple, right? Because the meaning of what we want to do is right there in the code. If you look at the code, you can see, okay, you just want the get personality of the person with this name, which is a string, and you want the personality as it's typed. It's well typed, it's well written, this is a readable code. Why can't an LLM read this and do it? So that's what we were thinking when we started working on this entire project called Meaning Type Programming, or MTP. So let's see how we can do it. We built something called MTLLM, which is a library, a Python library that you can import. I'll talk about what Jacklang is in a second. So we can write this code like this, and you can see I have this function body called return llm.invoke. LLM is basically imported from MTLLM, and you can see it's just a model that I instantiate, and I say llm.invoke get personality function, name is name. So what I'm doing here is I'm using what this MTP is doing is it's using the semantics that are already existing in the code to generate a prompt for you. So it's not like creating its own semantics. It's just everything that you put in there is in the prompt. Like the personality type, like you can say, okay, it's a class. The LLM knows it's an enum. It's just you just need to get that semantic out of the code and just put it in the prompt. It's quite easy. So this we build with MTP, and it works really well. But the magic is not this. So this is where we did the actual thing. So this is a Python superset language called Jackson, and you will hear like 2 lightning talks away, basically. So this is a language that supersets Python. It's almost the same syntax, but a little bit different. But we actually introduced this by abstraction. The by abstraction right here, you can use that to basically do the same thing that I showed in Python. So it's a beautiful abstraction. It's very simple. It's quite readable. And it uses everything in the code to generate the prompt and do the work for you. For an example, we actually started writing this paper, and it's almost getting accepted in a top-tier conference, hopefully this year. To show you like how it would work, this is quite a nice example. So you have this, I have this game, Pygame, a game built out of Pygame, a very simple one. It's actually a tutorial on YouTube, not by myself, but I converted it into Jack and wrote this. You have a class called a position, and you have the walls, you have the map, you have the level. So basically what I'm doing is I am defining this getNextLevel function where we generate the next level, which is just the level object, and letting the LLM generate the object itself. It's not like generating code and running it, it's just generating the level itself. And on the left-hand side, the video that you are just seeing is OpenAI generating new levels as we go, each one much harder than the other. And it has been a great experience like using this MTP. So if you would like to see, yeah.
All right, thank you very much. Mehul, you are up next with the BERT Advantage. And then Jason, you are on deck. That will be our final lightning talk when we get to Jason.
Yeah.
Cool. Do y'all know what the best thing about elevator jokes is? They work on so many levels. Yeah. You know, I used to work in a shoe recycling shop, but I had to quit because it was just soul crushing. Yeah. Did you know that penguins produce an oil that helps all their feathers retain heat? That means the oily bird gets the warm. And you're good to go?
Yep.
Awesome, take it away.
Okay, so hello everyone, I'm Mehul. I'm a data scientist, and this talk is all about my appreciation for BERT topic, which is a topic modeling algorithm, and also my appreciation for PyOhio. So my journey in NLP started with this PyOhio talk in 2018 by Alice Zhao, where she talked about NLP sentiment analysis and topic modeling. And she did a lot of LDA, stuff like that, and that's how my sort of like journey started. And I thought what would be a good way, except like to give a lightning talk and honor her and the lecture. So let me just talk about topic modeling. So topic modeling is this idea where you have like a bunch of documents, you have a lot of documents, you have like unstructured data, and you're trying to essentially gather like meaningful insights from these thousands and millions of documents. And in the era of LLMs, that's a really important problem. So the way we used to do it earlier, or the way we used to do it in 2018, was that you would have something called an LDA model, and you would have to do a lot of work. You would have to pre-process the data. You would have to import spacey, stuff like that, and build a bag of words model, build a GenSem model, do like have hyperparameters, have topic cluster numbers. That's just a lot of things you have to do to get meaningful topics. And I think the whole topic modeling has aged really well. So coming to the modern times or the post-LLM era, all you have to do is call BERT topic, do like a scikit-learn kind of thing where you do fit transform, you pass in the text column which you have, and you get the topics from your data. And this is really helpful when you have, let's say, thousands of documents. You don't know how many clusters you would have. So something as like a exploratory analysis, this is really helpful to understand your data. The good thing about BERT topic, or the good thing about things that you can do now in topic modeling, is that they come with a lot of useful visualizations. So for example, you could have something like this, which gives you like a cool visualization about, let's say, all of your data, how does it look? You know, it colors it and everything for you. It gives you useful topic names on top of your data. Or you could also have something like this, which again like colors your data into clusters and has like useful topic names. And finally, I would also like to call out that you can pair these topic modeling algorithms with LLMs. So you could have BERT topic use LLM as part of its stack, of its topic modeling stack, and build the same kind of topic representations for you with useful names. So earlier they were like names with using words from the documents. Now they are like useful names that the LLM has abstracted, and it really gives you like an overview, or really gives you a good idea of the number of topics you have, of the number of like what does your data look like. So you can, you know, like build all of these cool downstream applications like RAGs or like question answering systems or maybe classifiers. It all starts with exploring your data first, understanding what sort of like clusters or what sort of topics does your data have. It also helps with debiasing the data. So there's a lot of these text data sets have bias in them, implicit bias, historical bias, stuff like that. So yeah. So while I don't know if LLMs will lead to AGI or not, they've gifted us with this ability to explore the data more comprehensively and ultimately leading to scalable decisions. And thank you. That was my talk and my appreciation for...
Sorry, I clapped too soon. I'm sorry, I clapped too soon. That was my fault.
No, that's okay.
Okay, cool. All right, thank you very much. Jason, you are final lightning talk speaker. While Jason's getting set up, I had some frustrating news this week. I finally bought the limited edition thesaurus that I've always wanted, but when I opened it, all the pages were blank, and now I have no words to describe how disappointed I am. Yeah, I also had a rough day recently, and then somebody went and ripped the front and back pages out of my dictionary, and so it just goes from bad to worse.
Okay, cool.
Okay.
All right.
Cool.
It's an absolute pleasure to be here today with you guys. And, you know, really I only have two things to accomplish in this talk. First, I want to convince you that our time is now and we matter. And we must act. So the next big shift is up to us. It's the time of the coders. So I'm going to convince you of that, and then I'll tell you a little bit about how we're trying to participate and create value with this mission and this mandate. So just to lead up to the case that this is precisely our moment right now, let's just observe the traditional computing stack, right? So everybody knows this stack. If you've taken any kind of computer science, anything, you've seen something like this. Start at the physics, you go all the way up to the application, through hardware, through programming language, through algorithm, et cetera. So we had a massive surge here in 2022 with ChatGPT. This changed the world. Everyone in tech is doing work at the intersection of their area and AI. And for many of us, that's becoming AI itself. And we're seeing a lot, since that moment, we're seeing a lot of feverish activity when it comes to the application realm. Like, what are the kind of tooling and frameworks for us to wield this technology and build something interesting, learn how to solve the world's problem, now that we have this capability of inference, this model technology. And we're seeing this in the market. We're seeing many, many companies coming out, open source projects, hobbyists, ideas coming out in the realm of the application space. But we've seen some stagnation here, right, in the stack. And this is a place that is incredibly close to the Python community and us as coders and engineers. We can dabble in all of the other realms, but I think this is the realm. We have the model. We have the hardware. And now we have to invent how to build the software, right? NVIDIA gave us the hardware. This is actually the timeline. This is actually the story. The transformer neural network was invented. The attention mechanism was invented so it can run fast on GPUs. Before that, we had something called LSTM. And LSTM was incredibly smart as a model. Indeed, we cannot prove it's not smarter than the attention mechanism, but the attention mechanism gives us the ability to train these models fast. Thank you, Google, for the transformer to run on your GPUs in the data centers. Thank you, OpenAI, for taking that transformer, adding reinforcement learning to it so that we can use it and it can tell us stuff and it can make us work better and faster. But now we see we're grappling with building the software and we're inventing things left and right. And in reality, in production, no one's using those inventions. In production, if you look at Codex, if you look at Codex, Gemini CLI, Aider, they're not using LangChain, they're not using Crew AI, they're not using AutoGen. The best agentic systems, Windsurf and Cursor, are inventing their own ways, even though we're in this landscape of rapid innovation. So we believe it's because of the fundamentals of the abstraction. And so I'll just tell you a little bit about how we participate in this realm. So Jayanaka, he's also a colleague of mine that's working with me on this. And he got to sign up quicker than me. He got to the board quicker than me. And that's always, I'm always happy to see that. But we're working in this, we're contemplating, well, what should programming languages look like in this environment, right? It's a very different environment, and our languages haven't fundamentally changed since the 80s. So what should they look like? And so we're working on that ecosystem, and we're building it as a Python library and as a language. We're going the TypeScript route. So we can invent the stuff, but make it very easy to adopt. So you can use decorators or the language, and you have the same access to the abstractions. So that's point 0. We're supersetting Python natively. Everything's Python. We are adding abstractions for AI, as Jayanaka showed. We have more abstractions that are really important. We're contemplating what an object is, and should an object be an agent? This is an interesting question, and we have something for that we think matters. And we also believe that we should be able to build our software with the assumption that it will scale to millions of users. So you can write it for your desktop and not change the code, and then also launch it and this is the same code. So how do you do that? There's actually real stuff built on this, and now we're releasing it to the world. We're going to release it to the world soon. Thank you so much. Join us. Thank you. So close. Thanks.
All right. Thank you, Jason. Thank you, everyone, for coming to Lightning Talks at PyOhio 2025. That is it. That is the show. I hope you had a good time. Let's put your hands together and thank all of our Lightning Talks speakers one more time.